Let's continue using the quadratic formula, but now to solve an actual problem. I see a word problem. I see a formula. I'm assuming that I'm going to have to use this formula. And why not write it out so that we extract it. The other thing, too, is that, in my opinion, for a lot of people, it makes it less overwhelming when you go and you actually look at the words. Space travel, the height h of an object, t seconds after it is propelled upward with an initial velocity. So something's getting like launched into space and may or may not come back down. Let's find out. The height h of an object, t seconds after it is propelled upward with an initial velocity of v, is represented by h equals negative 1/2 gt squared plus vt plus h, where g is the gravitational pull, and h is the initial height. Suppose an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the balls 2 meters above the ground. Also, this is gravity on Earth, which is 9.8 meters per second squared. By the way, that's meters per second squared. That's the units. While on the moon, it is 1.6 meters per second squared. All right, now here's the deal. Where is this individual at? Well, he is on the moon, throwing a ball upward. Because of that, we're not going to use 9.8. We're going to use 1.6 meters per second squared. So we go in and we plug in all these values. Let's see, we get equal sign comes down, negative 1/2. I track down g. Well, g is gravity, and that's 1.6 meters per second squared. There's no need to convert, assuming the rest of the problem is also in meters. I move on from g to t, which we don't know. That's our variable. Plus v, which is 10 meters per second, times t, which we don't know, plus the initial height h, which showed up as 2. Now let's simplify this. Well, I know that half of 16 is 8, and that I make sure I don't mess this up. I'm going to write negative 0 and 8/10. T squared plus 10t plus 2. And we're given decimals here, so it's okay if we continue to use those decimals. And what we're doing to solve this is that they ask us nothing, I think. So now we need to add a, well, basically, when is it going to hit the ground? So when will it hit the ground? Well, its height would be 0. So we'll go ahead and we'll set the left side equal to 0 now. I dislike dealing with negative a, and because of that, I'll go ahead and I'll flip the signs on all of these. Doesn't matter, because this will come positive. So I got 0 and 8/10 t squared minus 10t minus 2. And that means that our values for a, b, and c are now 8/10, negative 10, and then negative 2. So you can probably pause the video and on your own this, knowing that like whenever you're dealing with the radicals now, it's going to be okay to end up with decimals. But we'll rewrite the formula, negative b plus or minus, and I'm going faster because I'm assuming this is getting more routine. And I can even talk while I write this down, so that kind of tells you how memorized that is. So we got negative 10, which is positive 10, plus or minus the square root of b squared, so we're going to have negative 10 squared. This time I am going to plug the values all in, times 4, times a, which is 8/10, times c, which is negative 2. I like to look for patterns in these things. You know how I had said earlier that it didn't matter when I flipped the signs on here? Well, check it out. In the formula, it's going to make this sign different. Well, that's never going to matter. That's always going to be a positive value. And if I flip the signs across the board, well, then this reverses, as well as this, so that if that was positive and that negative, they just kind of flip around. So no matter what, I'd end up with the same result in those guys. Okay, 10 plus or minus. Now we got some crazy stuff going on here, but we'll show our steps. Here's 100. Minus 4 times 2 is 8, times 8 is 64. And I think that's going to end up being a positive 6 4/10. Well, this would be 2 times 0.8, which is going to be 1.6. Now, there might be a part of you that's like, oh, that's cool. I know I can take the square root of 64 and the square root of 100, but those are combined together. So don't make an assumption there that that's okay. And here's where I look at this and I say, well, it's time for the calculator. So plug this into the calculator where you take all of that divided by 1.6 and then go back and erase those first parts of the results, taking all of this and substituting in that minus sign and then dividing it by 6. And hopefully you get that x, or in this case capital H, is approximately 2 values measured in seconds. Those two different choices would have been 12 and 7/10 or negative 2/10. And since this wouldn't work for our problem, and actually if you think about the graph of the quadratic function, it's kind of a little bit interesting. Here he is throwing it 2 feet in the air, right? So the parabolic function, moving forward in time, if you were to like reverse it in time and he had never tossed it to begin with, it would have landed back here negative 2/10 of a second ago. And since we're crossing that out, it would probably be nice to summarize this by a ball thrown on the moon and really under those conditions, because if you threw it harder, it would be in the air longer. A ball thrown on the moon can stay in the air 12 and 7/10 of a second. And if you're interested, go back and redo this formula, substituting in the values for the Earth. Because you could compare it and see how much longer or shorter it would be. Use your guessing to figure out what you think it would be. The discriminant. Now go ahead and grab your textbook, turn to page 496. Here's where the discriminant plays an important role. You have all this stuff with the quadratic formula, but let's look at where this plus or minus area comes in. This is the plus or minus region, and that means that all of that is dependent on the values here for b squared minus 4ac. So the discriminant is shown by b squared minus 4ac. Go ahead and write that in and draw an arrow to the discriminant so you know where it's at. But as you're looking at 496, let's talk about what these implications are. So let's think about the formula as you're looking at both this and your textbook. Now, I didn't include this because I just think it's kind of logical, but here I'm going to kind of show a cloud around here. Now this means that we're going to have 3 different possibilities. One possibility is that we plug a bunch of stuff in here and we end up getting all of this as values that are less than 0. And that's just another way of me saying negative. Well, if it's less than 0, then there's really no real answer to that, because as we've seen in the past, we can't take the square root of a negative number. So this means that there would be no solutions. So on your table on this page, you'll see a key talking about, if it's negative, there's going to be no real roots. And what this tells you graphically is that your graph is somewhere hovering above or below the x-axis, but never crossing through the x-axis. Now back to this whole deal. That was where it was negative. There's also a situation where if I take b squared, like let's say it's 4 squared, or better yet, let's say it's 6 squared. And maybe you're in a situation where 4 is 4, a is 1, and then c is 9, which would mean that this would become 36 minus 36, or just 0. And if you were to add or subtract 0, then there'd really be no change to that. And so because there'd be no change to it, you would only have these parts that mattered, because I wouldn't be adding or subtracting anything to it. So there'd be no plus or minus, which means there'd be no two options. So in the case that the discriminant is equal to 0, that means there only is one real root, or a double root. So that means your graph is just barely touching the x-axis at one location. Like I said, I think this is logical, so hopefully this guide is helping you see this. Now the other situation is, well, what if this was instead positive? And we've already done problems like that. And if it were positive, that means you would be adding something, you would be subtracting something. So if b squared minus 4ac was positive, you're definitely going to have a graph with two real roots, and so on, where it crosses twice. So again, negative, these numbers wouldn't exist in the real world, so it means your graph is either floating above or down below. And if it's 0, that means that you're not going to add or subtract anything, so you only have one solution there, which would be the double root. And then if it's positive, that means you'd have two places where it crosses the axis. So, that's, in my opinion, kind of clear to see. So if you want, take that discriminant, put it on a vocab card, study the graph as well, put the graph on a vocab card, all that kind of stuff. So this says state the value of the discriminant for each equation, then determine the number of real roots. Now, I will not be referencing the table directly here. I'm going to be reasoning through it just to say my point. Okay, now every time I want to use the discriminant, I'm going to write b squared minus 4ac. It's just going to be that many more times you practice this concept. For this particular problem, b is 10, so I'm doing 10 squared minus 4 times 2 times 11, and I've plugged everything in. Even though these are probably rote, I'm going to rewrite these problems in my notebook so that I have something to look at later. 100 minus 4 times 2 is 8 times 11 is 88. And already we can probably judge that this is positive, and we could run to this next step, but they do want to know the value, so we're not going to just stop there. So we're going to say 100 minus 88 and get 12. And box that since they say to state the value. Now, since we do have something, this means that if I visualize my quadratic formula, I would be adding or subtracting something. So this tells me that I have two real roots. I've satisfied all the expectations of this particular problem. And so, if I wanted to jump back to the table for reference, I could look down here where I've erased it, which is not helpful. And I would see that under the part where it says I have a positive discriminant, I do have two real roots. Okay, this equation right here is not set up in standard form. So probably you're able to be like, well, c is going to be positive 2. But for our notes, let's not cut that corner. And we'll rewrite this as 3m squared plus 4m plus 2 is 0. So that when I go in and I plug these values into my discriminant, which is b squared minus 4ac, I'm going to do 4 squared minus 4 times 3 times 2, and I'll get 16 minus 4 times 3 is 12 times 2 is 24, which means I have negative 8. Back to that whole deal. Maybe I'm picturing quadratic formula, where I have plus or minus the square root of something. The discriminant is under my radical. That means that I cannot take the square root of a negative number, and this means there are no real roots. And if I wanted to, I could look at the table where it's negative, and it tells me that the graph doesn't cross the x-axis, and it would also tell me that I have no real roots. We're not using the quadratic formula for problem 3. And I mention that because sometimes it's nice to simplify by dividing everything. We're only using the discriminant. So maybe it would save us some time to divide by something, or maybe not, whatever you prefer. But I'm talking through that anyway because as I look at this, I'm tempted to divide. But as you see, 4 can only be divided by 1, 2, 4 to get nice whole numbers. 20 works that way, but 25 doesn't. So that was just me kind of exercising the thought process to coach you through ones where maybe it would save some trouble. It's already set equal to 0. Make this an OYO problem, pause it, and then compare it with what I have in about a moment. Hopefully you rewrite the formula, and then you're going to have negative 20 in parentheses squared minus 4 times 25. All of those a's and c's are positive, so 20 squares gives me 400. And what's an easy way to do this? Well, 4 times 25 is 100, times 4 is 400 all over again. So this would be 0, and hopefully you put that this is 2 real roots. I like to write the word 2 out, since we're in words, and professionally, one shouldn't start a sentence with a number unless it's greater than 100, I think is the rule. Okay, I went through and I changed the assignment here because I had it wrong in your notes, so can you update that? It says 9.4, solving quadratic functions by using the quadratic formula on page 497. And notice this, 1 to 41 odd. That's a new thing. The reason I'm doing that is because let's say you do roughly half of the number of problems if we did all. That would be 20. That's about 20 times of using this formula. I think that's pretty reasonable for getting in a routine to where you're kind of just going through these very procedural problems to lock the standards in place. Questions about it? Let me know.